Hello, this is the video for protein binding assignment. Let's see what the question asks for. First, number of, as I have always said, you have to look into some of the information. The drug is an acidic drug and it's lipophilic drug, eliminated by liver only. Eliminated by the liver, and we have its intrinsic clearance of free drug, and steady state volume distribution, and we have free fraction in blood, FUB, in a 7 kg patient. So now, and also it is giving you some information. IV dose 62 milligram administered every 4 hours. Now, first thing we have to do is the calculation of apparent volume distribution related to the distribution of the drug in the extravascular space, which is VT. So what we have to do, we have to calculate. First, we have to use this equation: VSS is equal to VV plus FUB divided by FUT VT. Now we are going to calculate this VT. You are going to calculate, there is no change here. We can just write it VT is equal to VSS minus VB. And what is VSS? Which is 100. This is the VSS. 171 minus 4.9. So this would give you 166.1 liter. So this is our apparent volume, apparent tissue volume or extravascular volume. So first thing we have learned how to calculate VT. So our VT is 166.1 liter. And then we have to calculate clearance, as it is asking that the drug is mainly eliminated by the liver, so we'll calculate liver clearance. To calculate liver clearance, if you remember, from liver clearance we have to use this equation: CLH is equal to Q times E. We know Q is this one. So we know Q is equal to 1500 milliliter per minute. Now we have to calculate E. We do not have any information or any data on E. For this reason we have to do some steps. To calculate E, we have that equation. If you remember, CLINT divided by Q plus CLINT. If you know the CLINT, in our notes we have described it: hepatic intrinsic clearance. But what we have in the here, it is intrinsic clearance of the free drug. So for this reason we have to do another steps. CLINT is going to be CLINT of free drug times FUB. We have both of this information. You see here CLINT, we have our CLINT here, and FUB. What we do, we just multiply. which is 140,000 times 0.5. This will give us a 70,000 milliliter per minute CLI. Means we have this hepatic intrinsic clearance is this one. So now this value we have to put here in this equation. So what we are going to do, E is equal to CLINT, we know it is 70,000. We know Q 15 plus 15,000 milliliter per minute, 1500 milliliter per minute plus 70. So this will give an E of 0.9792. So this is our E. This E we have to use here. Let's go back. This E we have to use in that equation. So now let's rewrite this equation. CLH Q times E. We have Q is equal to 1500 and we know that E is 1500. E is going to be 0.97902. Our CLH is going to be 1468 milliliter per minute, which if you convert to liter per hour, it is going to be 88.1 liter per hour. Okay, so this information, I think the answer asked for as the question in clearance in milliliter per minute. Let's see. Clearance is asking for milliliter per minute, so our answer is 1468 milliliter per minute, and we'll need this thing later in liter per minute. So for this reason I had converted it before to 88.11 liter per hour. Now we have to use those data to calculate this number of parameters for plasma half-life. We already know half-life. We have to calculate T half 0.693 V divided by CL, and we know what is our V from our problem. From our problem we know what is our V. V is 171.693 times 171 divided by CL. CL it is in liter 8. So this is going to be give us a half-life of 1.349 hours. So this is our half-life, 1.349 hours. Then average steady state concentration. You know that in each time you have to go back to some earlier lecture note or equations. So we have to calculate this C average. If you remember this equation, dose by tau divided by CL. So now we have to find out What is the dosing rate? You see this dosing rate, this is the dosing rate here. Now we're going to put 62 milligram per 4 hour divided by CL, which is this one, is 88.11 liter per hour. So this will give us 0.1759 milligram per liter. So that is going to give us total average steady state. It's going to be 0.1759 milligram per liter. Remember this. So when we said this total means C average total, that means here we have free plus bound drug. Now next question are asking to average free steady state concentration. So this is easy. You know that fraction, it is C average is equal to C average free drug. Free drug is going to be C average total times FUB. So we know that total drug is 0.175913 times FUB is 0.5. It's going to be 0.0879 milligram per liter. So our free drug concentration is 0.0879 milligram per liter. As you can see, we compare these two and this one, which one is higher? Total drug. Total drug is always going to be higher than free drug concentration. Now some of this drug may be characterized as large V low CL drug, large V high CL drug. This is going to be large V high CL drug for a number of reasons. First, it has high extraction ratio. What is the extraction? If you I think I have removed that, deleted that answer. So I think extraction ratio was it had a E is equal to 0.97902. So when high extraction ratio, if you remember, high extraction ratio in case of CL is equal to Q. So because of high extraction ratio, it has very high clearance. High extraction means high clearance. And large volume distribution, large volume of distribution, when if you look into the fraction unbound is 0.5. So fraction unbound is 0.5 and remaining is distributed all over the body. So it is large V high CL. And another way to find out why it is large V, you see this tissue volume is very little. So tissue volume, apparent tissue volume is here, and then it has a very large steady state volume. This number of information will help you to determine if it is high V or high CL drag. I will try to explain this thing more in the class. In plasma, this drug is expected to primarily bind with albumin. It's because this is acidic. Free fraction of this drug in the blood is expected to free fraction. You have to read carefully. Free fraction of this drug is expected to decrease in cirrhosis. What happened in case of free fraction? If you go back to our protein binding lecture, if you go back to our protein, what happened in case of liver cirrhosis? Here, liver cirrhosis reduce albumin concentration. Burn, surgery, acute renal failure also reduce albumin concentration. So liver cirrhosis reduce albumin concentration, and renal failure also reduce albumin concentration. So now go back to that. Let's go back to that number 8. So in case of number 8, let's see, has to be free fraction. In case of burn, it should increase because burn reduces. Let's go back here. In case of protein binding, protein binding. What's going on with my computer today? Again. So when in case of burn, surgery, renal failure, reduce albumin concentration. Synthesize and liver disease also reduce albumin concentration. So in case of free drug, in case of cirrhosis, it cannot decrease. Free drug concentration cannot decrease, it's going to increase. So in case of burn, in case of burn, what is going to happen in case of burn? Free fraction is going to increase. So free fraction is going to increase in case of burn because burn causes albumin concentration will go down. So when albumin concentration go down, free drug concentration is going to increase. In case of liver cirrhosis, free drug concentration should also increase, cannot decrease, because cirrhosis, albumin will go down. So free drug concentration should increase. Now, the second part of this problem. If a disease state, FUB of the drug is decreased by a factor of 2. So that means we have a new FUB. We have a new FUB which is 0.25 by a factor of 2. That means we have 0.5 by a factor of 2, 0.25. So this is all other things are same. So only thing we have changed is 0.25. So what would be the steady state volume? Steady state volume, now number 1, let's go back, VSS, if you remember the equation, VE plus FUB divided by FUT and VT. So what has changed? This one has changed, but there was no change here. So that means that this equation becomes, if you assume this is constant, that over there that it has changed. So now our VB, this ratio should be half VT. So because assuming there was no change in FUT, no change. FUB change to half. So you assume in that case there is no change, so we'll just eliminate FUT. So here now we have VB 4.9 liter plus half times VT. We know that here VT we have calculated. VT is this one. This is our VT, so we have to use this one. 4.99 liter plus half times 166.1 liter. So this would be 87.95 liter. So FUB decreased, fraction unbound decreased by factor, so that for this reason our VSS is going to decrease. So our new VSS is 87.95 liter. So again, if you understand this FUB, our initial FUB was 0.5. The new FUB because of the disease is 0.25. So now based on the equation 0.25, that means fraction unbound has decreased. So when fraction unbound has decreased, our volume of distribution is going to also decrease, because if you remember this equation I've been going over and over. What is, if it had gone up, VSS would go up, but in our case it has gone down, so VSS is going down. Now we have to calculate the clearance. To calculate clearance, we already know nothing has changed. CLINT, because FUB has changed. So to calculate clearance again we have to use that CL is equal to Q times E. So CLINT, we have to calculate CLINT times FUB. Our previous CLINT initial is for 140,000 times 0.25 is equal to 35,000 milliliter per minute. So this is our hepatic intrinsic clearance. We have the data on intrinsic clearance of free drug. Now you calculate E again. CLINT divided by Q plus CLINT is equal to 35,000 divided by Q is always 1500 plus 35,000. Here again E is going to be 0.9589. So as you can see, E has gone down a little bit. What was our E? What's going on? So E has gone down a little bit. Now we are going to calculate CL.
Cl is equal to Q is 1500, and then this new E we are going to use 0.9599589 is equal to Cl is going to be 1438.36 milliliter per minute. So our new Cl. So because of this change in the fraction unbound, we have a new Cl. So let's write down that new Cl. Our new Cl is 1438.36 milliliter per minute. And then to calculate T half is in hours, so we have to convert it to, this is going to be 86.30 liter per hour. Okay, so we have now 86.30. Now same as before, we have to calculate, use this new Cl. See, this is all a domino effect. When one changes, everything changes. So now T half equal to 0.693 V times Cl is equal to 0.693 divided by Cl is sorry, V is 87.95 liter. This the new V, 87.95 liter. Here is the new V. Our new V we have to use here. 87 and divided by 86.30 0.7062 hour. So this is our half-life, new half-life. See, this half-life has also changed. Our new half-life is 0.7062 hours. Now again, same thing, using this new half-life, we have to calculate steady state. Using new clearance, we have to calculate C average. What is the C average equation? Dose divided by tau divided by Cl. When Cl changes, always things gets complicated. So our dose we know 62 milligram per 4 hour divided by our new clearance, which is 86.30 is equal to 0.1796 milligram per liter. So this is our total. So our total C is 0.1796 milligram per liter. Now free average steady state concentration. Free average steady state concentration, we know C average free is equal to C average, this is total, times FUV times FUV. So C average is 0.1796, FUV is 0.25, which is going to be 0.0449 milligram per liter. So here our total, this was our total. Now free is 0.0449 milligram per liter. As you can see, in the presence of altered protein, the dosing rate should be
increase, decrease, it will maintain the same. You see here the free concentration. Free concentration, we know that free concentration, this is the drug concentration responsible for therapeutic effects. So this is the free concentration, but healthy individuals free was this. You see the concentration has gone down, just half. So for this reason, if you want to maintain, so dosing rate should be increased. Dosing rate should be increased. That's all I had. I hope this was very straightforward and easy video. I think I have one more assignment video to post, then I'll be done. I will say you goodbye forever. Thank you.